Hello, Algebra 1. We're on the first part of 8.4 today. We'll be in 8.4 for 2 days and work our way up to 8.5, and it all kind of goes together. Where we're trying to get, now that we are done with multiplying fractions, and we're done with dividing fractions, although they're not called fractions in this chapter, they're called rational expressions, but in essence they are fractions. We're finally going to do some adding and subtracting fractions eventually. They saved adding and subtracting for last, even though that's usually what you do first, because it's probably the hardest one. Because you probably remember from basic fraction life, if you're going to add fractions, you first have to pick a common denominator. And that's what we're going to learn how to do today. After you get the bottom chosen, then if you're going to change the bottoms of fractions, you have to change the tops. And that's what we'll do tomorrow. And once you manage to do all that, then you're going to actually be able to add or subtract the fractions, and that's like 3 lessons away. So today we're working on just finding a common denominator if you have 2 fractions. On the notes paper you have from your packet on 8.4 part 1, I wrote on that packet the complete fractions. I just made up tops for every fraction. When I copied these to the board, I didn't even write the tops, because today the tops don't matter. All we're doing today is trying to choose the bottoms. So if I had written the tops, we would have ignored them anyway, so I saved some time and chalk and effort and just didn't even write the tops, because all we're doing today is trying to find a common denominator. So the way we're going to look to do this, like everything pretty much in this chapter, you're going to start off by factoring anytime you see adding or subtracting. After you factor, then we're going to choose each factor we can see the most times that it appeared anywhere. The first few we won't have to factor, so I'll recap that synopsis when we get to the ones that matter. But if we go back to like 7th grade days, 3 and 2 both go into 6, so the answer is 6. We prefer 6 because that's the smallest number they both go into. This is called sometimes an LCM, least common multiple. Today we can call it the LCD, the least common denominator. Whatever you call it, it's the same thing. We're seeking the smallest thing that everything can go into. 6 is it there. For 8 and 12, smallest thing they go into is 24. 24 is the least common denominator, least common multiple, whatever you want to call it. In terms of strategy, for a lot of people, you just can kind of look at the numbers. Well, for some people, look at the numbers and you're just kind of like, be 24. And if you don't have that skill, if the numbers don't appear to you from the heavens, we need a strategy. So one strategy would be take the bigger number and just count through the multiples of the bigger one until the littler one can go in. So 12 itself, 8 won't go in. So take the next multiple of 12, 24. Can 24 be divided by 8? Yup, so 24 is it. Whatever this number is, if I just counted through 12, 24, 36, 48, 60, 72, on and on, sooner or later, this number would have to go into one of those. If you get bigger numbers than you can manage in your mind, use a calculator to help you keep doing stuff divided by this, stuff divided by this, stuff divided by this. You would need to keep making new multiples of this, and eventually 8 will go in. So if we were trying to use that strategy here, I would just count through my 20s until 12 would go into something that's in the 20s. So 20 itself is a failure. We can't divide that evenly by 12. 40 is a failure. That won't divide by 12. 60 is not a failure. 60 can divide by 12. So 60 is the answer for that. Another way you could do it, but I think it's longer, is to do factor trees. So if we did a factor tree here, we could go like 4 and 5, 2 and 2. This we could do 4 and 3, 4 becomes 2 and 2. At the beginning I said one way to do this is to take each factor the most times you see it. So for this problem, I see a 3, once is the most I ever saw it. I saw a 5, once is the most I ever saw it. I saw a couple of 2s here, I saw a couple of 2s there. They tied for most, but if you take 2 times 2 times 3 times 5 and do it out, you get 60. That works. That's what books a lot of times teach. I think that's harder. I think it's more confusing and longer. I think your easier strategy is often take multiples of the bigger number until the little number goes in. But if you got two giant numbers, then you probably would want to resort to this factor tree thing, because if we were doing multiples of like 587, maybe you don't want to do multiples of 587, but factor tree maybe if it was big to break it down. But I don't think our book will do that to you, so I'm not worried about that. This I work in some variables, so I'd start with the numbers. Starting with the numbers, looking at 10 and 12, thinking of what 10 and 12 both go into. Some people might right away think of 60. If you're not one of those people, count through your 12s. 12, 24, 36, 48. 10 won't go into any of those until you get up to 60 in your 12 times tables, so we use 60. For the variables, and for everything we're about to step toward, we're back to the idea of pick everything the most you see it. So when we look at these, I see A's in both of them. The most I ever saw with the A's is the 3 from this one, so I'm going 3. I also see B's, and I think, who's the most? The word of the day is most. The most B's I ever see in one location is 2. We're not trying to count the total everywhere we see, we're just looking for the most in one setting. So it's not like, hey, 3 and 1, let's do 4 of them. No. 3's competing with 1. The winner is the one you had the most of. Here I did again 10 and 12, so again we're going to go 60. For the X's, I'm going to go 5 is the most. For the Y's, the most I see is 7 from here. 7 beats 4. And I sneak the Z into this one, and even though that doesn't have a Z, I'm going to take a Z. Because again, the word of the day is most. We take the things we see the most. When I step over to the next column, what we need to start to do in the next column is start to try to factor. If you see any adding or subtracting going on, we're going to have to factor to see what's happening. So this I have a GCF of 5. This I have a GCF of 4. If you want to practice your factoring, maybe pause the video and go factor crazy and just see what you have. I'm just going to go factor crazy for a minute. So 4, x plus 3, 6, x plus 3, 4, x plus 5. This is a difference of squares, x plus 5 and x minus 5. Up until this moment, those were all just GCFs, taking out a greatest common factor. This, we have 2 groups of parentheses, x plus 3, x plus 2. My own chalk, we'll squeeze one more out maybe. X plus 4, x plus 2 from that one. Now with the numbers, just do what we've been doing. Okay, with 5 and 4, I'm going 20. For this one, with 4 and 6, I'm going to go 12. For this one, with 4 versus an empty space, I'm going to go with 4. We have to take everything we can see. This one has no numbers, so we're good on the numbers with that. Then we look at the factors, the groups of parentheses that we've created. I have an x plus 2 in everything, so I only need to take an x plus 2 once, because the word of the day is most. There was 1 here, there was 1 there, you only ever saw 1 at a time, so just take 1. This, likewise, I only have to take an x plus 3 once, because there's 1 here, 1 there. The fact there's doubles on the board somewhere, we don't care. We care about the most from one fraction. This, I see an x plus 5, and I see an x minus 5, which is different. I see 2 different kinds of factors. I don't need any powers yet, because the x plus 5, when I see it, I only see one of them per fraction. This last one, I see 3 different fractions, or 3 different factors, excuse me. So what I'm going to need for this one is to take an x plus 3, because I see it, take an x plus 2. Even though I see it twice, it's once here and once there, so just once. X plus 4 is happening over there, so I take it. I believe when we step to the next column here in a second, we're going to see sometime the need to do a power, because if you're wondering, are there ever powers on this? The answer is yes. If we were doing factoring and you got two of the same in one fraction, then powers are about to appear. If you feel like you have this, pause the video, see if you can do the other problems, and then catch back up to me. But stepping this way, I'll start off with factor mania is 3, and the difference of squares will be minus x plus x. Ultimately, I'll stick the answer right about there. This, I have x plus 5, x minus 3. So those are gone. This is going to go x plus 4, x plus 4. I could write that as a square, but I don't need to, so I won't yet. If you want to, you could. It doesn't really matter. This is x plus 4, x plus 3. This, I'm going to have to guess check. With 4x squared, I usually guess 2x, 2x. Especially if that's an even. I'm willing to go even heavy there with 2's because the middle is even. Plus means these are the same, and they have to be the same as this. And then with 3, I can only do 3 and 1. To verify if I guessed right, multiply these two, is 6x. Multiply the outer two is 2x, that is 8x, and we're good. Over here, we're trying to factor this. With 6x squared, I'm going to think 3x, 2x. With plus, I'm going to go same as that, so pluses. And then with 6, I'm going to probably go 2, 3 again. I'm pretty suspicious of the 6, 1 pair generally. I don't usually use the pairs with 1s unless this is really big compared to the other numbers, and that it is not. So I'm thinking 2, 3. I'm trying to get an odd, so don't overload this with evens. If I go even here, if I go evens both slots, that's even overload. That would have to produce an even. So I'm going to partner the odd number with the evens group, the even number with the odds group, and I like my chances there, but let's check to be sure. There's a 4x on this, there's a 9x on that, that is 13x, so we've replaced that as well. So again, step 1, factor, like it is every time. You see adding or subtracting, you have to factor. And again, the tops, in your homework problems, you probably had random whatever was on the top. You're not even looking at the top. I just threw that in there a second ago. It doesn't make any difference. The tops don't matter. Just looking at the bottoms to pick common denominators today. Tomorrow, the tops will matter. For this, we're looking around. What do we see? We see a 3 minus x. 3 minus x and x minus 3 are kind of the same. So I'm going to just pick either of them. If I picked this one instead, I'd be fine. I don't have to take them both. I just pick one. They aren't truly exactly perfectly the same, but for factoring, LCM, common denominator purposes for today, we're going to call those the same. Tomorrow, that'll cause a small issue with the negatives again coming back in. But today, we're good. 3 plus x is different, so I need to grab it because I see it. Anything I see, I grab it. This, x plus 5, I see it, so I have to take it. So we're going to go with an x plus 5, 3 different items. On this, I only see 2 different kinds of things. I see x plus 4s around, I see x plus 3s around. So if I see them in the problem, they have to be in the answer. And finally, we get our first power of the day on these, because the x plus 4, we got 2 from the same area, 2 from the same fraction. So that's going to make me have to square that this time. Not a lot of powers in these, but they can happen whenever you factor and get 2 of the same from the same problem. We'll need to do that. This, I see 3 different things. I see 2x plus 3 in this one and that one. I see 2x plus 1 only in one of them, but if I see it, it comes. And then the other thing that I can see that needs to be in the answer is a 3x plus 2. And that's just about it for today. So tomorrow we would do kind of a repeat of this. So if you can get strong on this, big advantage for tomorrow. Because tomorrow's problems, we're going to do the same pick a bottom thing, but then we're going to have to change the tops. And you want to be strong on this and the next, because after we can pick the bottoms, and after we can change the tops. Then on day 3 of this life, we're going to have to then try to add the fractions together. That's common, that's what we're building up to, but this is our first baby step. So if all is well with you, email me if you have questions. If you're getting confused about anything, I'm here to help you. Hang in there, everybody.